This is Geometry Lesson 6.2, Chord Properties. Okay, so I have a big circle here, and I'm going to draw a few chords on that circle. Chords, from the last section we talked about, are segments that go from one side of the circle to the other side. And I'm going to attempt to draw these chords to be congruent, so the same length. Hopefully those are about the same length. Then the first statement says if the chords in a circle are congruent, then they determine two central angles. So I'm going to draw some central angles on those chords. And if we were to measure these, if they actually drew them correctly, this central angle here would be congruent to this central angle here. Now, whatever those central angles are, the arcs out here would also be congruent, and they would be the exact same measure. So whatever big this is, I'll just say x degrees. This would be the exact same x degrees. This would be the exact same, and this would be the exact same. So if one of these measures was 100 degrees, I would know all four of those measures was 100 degrees. So to complete that statement then, if the chords in a circle are congruent, then they determine two central angles that are congruent. And their arcs are congruent. So the central angles in the center are congruent, and the arcs on the outside would be the exact same measure. My next statement reads, the perpendicular bisector of a chord blank. So I'm going to draw a chord, different chord, and then I'm going to draw the perpendicular bisector. So remember, bisector means it goes right in the middle, and perpendicular, it should be 90 degrees. So if I keep this going, it should always, always, always hit the very center of the circle. The perpendicular bisector of a chord passes through the center of the circle. And my last statement reads, two congruent chords in a circle are blank from the center of the circle. So I already have two congruent chords. I'm going to work with them. I have one chord right here, and I have one chord right here. The distance then from this point to the center and this chord to the center should be the exact same distance. We're going to use a fancy word to say the same distance, and that is equidistant. So using some of these ideas in a couple of examples, the first one shows a circle. My goal is to figure out how big is A, how big is B, and how big is C. The first rule we talked about was whatever angle we have at the center of the circle, the arc that has matching sides and points would be the exact same measure. So A is 95 degrees. To calculate the measure of angle B, I'm going to think back to my linear angle rules. Two angles right next to each other on a line always make up to 180 degrees. So if I do 180 minus 95, I will get that B is 85. Now, to get angle C, I need to recognize that this is a triangle, but not just a triangle, it is an isosceles triangle. The radius of the circle here would be the same as the radius here. So because I have two congruent sides, I'll also have two congruent base angles. So I can use my 180 rule on this triangle. That's just going to bring me back to 95. So I know those two base angles have to add up to 95 degrees. So if I take that and divide it by 2, we're going to split that 95 degrees between the two base angles. I will have 47.5 degrees. Example B, I see a 66-degree arc near the top and I see 1, 2, 3, 4, 5, 6 congruent arcs going around. I know that a full circle has to add up to 360 degrees. So if I do 360 degrees minus the 66-degree arc I have at the top, that leaves me with 294 degrees to split between those 6 equal angles. So 294 divided by 6. I don't know that one. Is 49 degrees. So that means that every one of these arcs is 49. Now I only really need to figure out the ones that are labeled. So I know W should be 49. The 49 here though is going to help me figure out angle Y. So if I have 49 degrees at this arc, that means the central angle would be the exact same measure. And then I'm going to look at this just like in example A, I have an isosceles triangle here. So these sides are the same. That means these base angles are the same. It's getting crowded. Okay, so on my isosceles triangle, these base angles will be the same. So if I do my 180 rule, take away the angle I know, that leaves me with 131 degrees. I need to divide that by 2 to split it between the two base angles. 65.5. And that will be my answer for letter Y. That is it for the notes. Good luck on the exercises, and please let me know if you have any questions.